Hi everybody, today we're looking at our last form of differential equation. And I've titled it an exact differential equation, and there's a definition there that if we've got the derivative of two functions in terms of x, and that equals some other function of x, so the derivative of two functions multiplied together equals some function x, some other function of x, then it's called an exact differential equation, and we can solve it by different means. Now, we're not so concerned with exact differential equations, we're more concerned with a differential equation in standard form, which means we've got the derivative plus some function of x times y plus, or rather equals, some function of xq. And we can make it exact and then go through and solve it by multiplying both sides by the integrating factor I equals e to the power of the integral of p of x, where p of x is that function multiplied by y. So this p of x here relates directly to this p of x here. So it's whatever function of x is multiplying by y. And then we can multiply both sides of this differential equation by this integrating factor y. Why does that work? Why does that make it exact? Well, let's think about it. So I'm talking about e dy dx plus px y equals qx. Now, I'm going to multiply both sides by this integrating factor, which means I've got e to the integral of p of x dx times by dy dx plus e to the integral of p of x dx p of x y equals e to the integral of p of x dx times by q of x. Well, how does that help? Well, let's think about it carefully. Let's call e, or rather u, let's say that's equal to e to the power of x dx. And let's say, well, v is y. Now, u dash is equal to, well, when we differentiate an exponential, it's just e to its power, so e to the power of p of x dx, times by the derivative of the power, so times by d by dx of the integral of p of x dx. Now the derivative of an integral is just the original function, so e to the integral, so this derivative is e to the integral of p of x dx times by p of x. V, where v is y, then the derivative of v is just dy dx. And so if you look carefully, what we've got here is we've got u, v dash, all of this is u dash, and this is v. So on this left-hand side, we have u v dash plus u dash v. And so what does that mean? Well, this is the derivative of u times v by the product rule. So what does that mean? Well, we can say therefore left-hand side is just equal to d by dx, the derivative of uv, which in this case, well, what did we say? Well, u was e to the integral of p of x dx, and v was y. And so then putting this all together, I can write the equation as, I can write it as d by dx of the integral, rather not the integral, d by dx of e to the integral of p of x dx times by y is equal to the function we had on the other side, which is e to the p integral p of x dx times by q of x. And so then this is in exact form. This is all some function of x, and this is the derivative of two functions of x multiplied together, because y is a function of x. Okay, let's have a look at how this works. So we need it in the form d derivative, so first of all we'll just write it out, so x plus 1 dy dx, take 3y is equal to x plus 1 to the power of 5. I need the dy dx on its own, so I'm going to divide through everything by x plus 1. That will get rid of x plus 1 in the first term. Second term I'll have 3 on x plus 1 times y, and in the third term I'll have x plus 1 to the power of 5 on x plus 1, so that will cancel, leaving me with x plus 1 to the power of 4. Now we need our integrating factor. So what is p of x? Well, p of x is negative 3 on x plus 1. So then I, which is our integrating factor, is e to the integral of p of x dx. So it's e to the integral of minus 3 on x plus 1 dx. And then to simplify things down, I'm going to take the minus 3 out the front. So it's e to the minus 3, which is the integral of 1 on x plus 1 dx. Okay, so that's a one-on function, and the function is linear. And so then we can just integrate it. So it's ln of the modulus of x plus 1. And then is x plus 1, we don't know whether it's positive or negative, so I'll leave it as the integral. Now, I will make a point that there is no plus c needed. And I might talk about that in class, because I don't want to spend too long. I don't want to make a really long video. So, we'll come back to that. So that's my integrating factor, so I'm going to multiply every side of my original differential equation by this. So it's that times dy dx plus, or rather minus, e to the minus 3 ln modulus of x plus 1 times by 3 on x plus 1 times by y is e to the minus 3 ln modulus of x plus 1 times by x plus 1 to the power of 4. And then this left-hand side can be written as the derivative, d by dx, of the integrating factor, e to the minus ln modulus x plus 1 times by y is equal to the e to the minus 3 ln modulus x plus 1 to the power of 4. And then I can integrate both sides with respect to x. So the integral of this side, dx, is equal to the integral of this side with respect to x. And I'm integrating a derivative, so the left-hand side will be e to the minus 3 ln modulus of x plus 1 y is equal to the integral of all of this. Now, what is the integral of that? Well, I haven't actually simplified my integrating factor like I should have, because there's an e and an ln there. So if I just think about my integrating factor, and I should have simplified it first, but I didn't, but that's okay. E to the negative 3 ln modulus of x plus 1 is equal to e to the ln x plus 1 to the power of minus 3. And the e and the ln cancel, so I just get the modulus of x plus 1 to the minus 3. So on the right hand side, what I'm actually integrating is I'm integrating the modulus of x plus 1 to the minus 3 times by x plus 1 to the power of 4. And on the left hand side I can change that as well. So I've got the modulus of x plus 1 to the power of minus 3. And here I can start doing some creative stuff. Now in the textbook they don't give us any reason to say that x plus 1 to the power of minus 3 is positive. They just kind of assume that. So really we'd need to say that this can just be written as 1 on x plus 3 cubed, assuring that x is greater than minus 1. So under the condition that x is greater than minus 1, so we'll say x greater than minus 1, and we'll take the modulus off there and there. So it's y on x plus 1 to the power of 3 is equal to the integral of x plus 1 to the power of 4 on x plus 1 to the power of 3. And then I can cancel that. So I'm integrating y, or I've got y on x plus 1 cubed is equal to the integral of x plus 1, which is just a half x squared plus x plus c. And so then y is equal to x plus 1 cubed, a half x squared plus x plus c. So when we integrate at the end, plus c definitely needs to be there, but just not at the start. Alright, okay. Now this one's a past exam question, and it'll be interesting to look at what they do with the integral of the integrating factor in the mark scheme. I'm just going to leave part A for the moment. We'll take that as fact, and we'll do it in class. We'll look at part B. So we've got, now they've been nice, they've given us the form here, dy dx, take y cos x is equal to sin x cos x. So what's my integrating factor? Well, p of x is minus cos x, and then e to the integral of minus cos x. Well, what's the integral of minus cos x? Well, the integral of cos is sine, so it's just e to the minus sine x, and then we know plus c. Alright, now, so we found our integrating factor. That was part B, it's just e to the power of sine x. And then the third part, and I don't have to bit too much space for that, is to solve the differential equation. So that means I multiply every section by the integrating factor. Alright, and then, so I can bring it together, so it's d by dx of e to the minus sine x y. You can just learn the fact that it'll always be the derivative of the integrating factor times by y. You don't have to work it out. So just remember, it's always the derivative of the integrating factor times y equals to the integrating factor times by the right hand side. So then if I'm integrating, well, I'm just going to get e to the minus sine x y is equal to the integral of all of this. And we see that we have found the integral of that in part A, which confirms that my integrating factor was right, just in case you're unsure. And just to double check, it's minus e to the minus sine x, 1 plus sine x plus c. And then I need to divide through by e to the minus sine x. So y will just be minus e to the minus sine x, 1 plus sine x plus c, all over e to the minus sine x. So y is equal to minus 1 plus sine x, in brackets, plus c, and hang on, I've done the wrong thing, haven't I? So I can cancel it out in the first term, e to the minus sine x there, but I cannot cancel it out there. So it'll be c on e to the minus sine x. And then we're told that y equals minus 2 when x equals 0, so I substitute that in. So minus 2 is minus 1 plus sine of 0 plus c on e to the minus sine of 0. So minus 2 is equal to sine of 0 is just 0, so that will be minus 1 plus c on sine of 0 is 0, so that would be e to the power of 0, which is 1, so minus 2 will be equal to minus 1 plus c, so c will be equal to minus 1. So putting all of that together, y is equal to 1 plus sine x, take 1 on e to the minus sine x. And let's just check the mark scheme. So it's interesting, that integrating factor was worth 3 marks, which is a lot for something that was fairly straightforward. But there it is, M1, A1, A1. Now, part C, so what were they looking for? An M1 and an A1. So you have to show multiplying the integrating factor by every part. Then another M1 and an A1 for showing after you've integrated the derivative. So you can go straight to this step where you've got e to the minus sine xy, and then doing the integral on the other side. And then they've basically substituted in a slightly different form of what they found. That gets a1, substituting x equals 0, y equals minus 2, gets c equals minus 1. So that was an m1 and an a1 for that as well. And so then writing out the final equation and then getting into the form y equals minus sine x, take 1. And I reckon I've forgotten a negative there, so yes, there's a negative out the front. Take e to the sine x, so all they've done is they've multiplied the minus by both, and they've said, okay, 1 on e to the minus sine x, that's a negative power, so we can bring it up to the positive, and we can bring it up to the numerator and make it a positive power. But I don't see any reason why they would take marks off for not simplifying. Okay. Alright, and we'll do the other bits and pieces in lesson.